function operations. Roman numeral 1 is pretty quick. Should be all review. Roman numeral 2 should be review, but it's stuff that you're not quite as good at usually. Because number 1 or Roman numeral 1 is review, we'll just work some example problems. We don't really need to talk about the theory or explain or anything. We'll just do some example problems to refresh your brain on what this is. So let's let f of x be 2x squared plus 2 and g of x be x squared minus 5x plus 4. Add, subtract, multiply, divide. We're not even going to do an add problem because you know how to add. Now, you're probably thinking, I also know how to subtract. Why are we doing a subtraction problem? Well, two reasons. One is the notation looks a little bit different. So f minus g of x, that means the same thing as f of x minus g of x. It's just a little bit easier way to write it, and so we'll usually write it this way, but it means the same thing as this. But some people, if they haven't been paying attention, they'll do f minus g and then multiply by x, but that's not what that is. It's f of x minus g of x. So 2x squared plus 2 minus g of x is x squared minus 5x plus 4. And if I stop right there, there's a big mistake in there. What's the problem? Go ahead, Ryan. Yeah, I need to subtract all of g of x. So, I mean, you know this, but this is a common mistake. If you're going to subtract g of x, make sure you subtract all of g of x. So, distribute the minus sign. Collect like terms. Let's see. 2x squared minus x squared would be x squared. 5x is the only x term. Overkill with the color coordination here. Plus 2 minus 4 would be minus 2. Or plus a negative 2. It means the same thing, so it's okay. Number 2, f times g of x. Again, this doesn't mean multiply f and g and then multiply by x. This means f of x times g of x. Or they can even write it as fg of x. So all of those mean the same thing. Multiply f and g. Two x squared plus 2 times x squared minus 5x plus 4. I don't know that I'd say cross multiply. Ryan, you're doing this. I think you're probably right. There you go. That's some good words, math words there. We'll distribute the first one to everybody. And then we'll distribute the second one to everybody. So it's not hard. It's just a little bit tedious. You got to be careful. You got to be neat. So 4x to the fourth. Whoops. How about 2x to the fourth? Minus 10x cubed plus 8x squared. And then we'll distribute the 2 to everybody. Plus 2x squared minus 10x plus 8. So 6 terms to keep up with. And look for like terms. But the only ones are the 8x squared and the 2x squared. So 2x to the fourth minus 10x cubed plus 10x squared minus 10x plus 8. Let's not factor it. Let's leave it like that. Number 3, f over g of x. F over g of x. And again, that doesn't mean f divided by g times x. It means f of x over g of x. Two x squared plus 2 over x squared minus 5x plus 4. And there's really not anything more I can do with that. Which is why for questions like this, we'll ask for the domain. I'm not why, but it provides us something else to do. So how am I going to find the domain of that thing, or what might be a problem for the domain? Denominator can't be 0. So x, you know what? Let's factor it. You wanted to factor the last one. No, thank you. But we can factor this one. 4 and 1, x minus 4, x minus 1. So x equals 4 and x equals 1. So is that my domain, 1 and 4? No. In fact, that is not my domain. That is exactly opposite the domain. X can't be 1 or 4. And so some people can go from there to the interval notation. Other people want to put it on a number line just to make sure. Can't be 1, can't be 4, can be anything else. So that would be negative infinity to 1, 1 to 4, 4 to infinity. All right, so that's pretty quick. That's pretty easy stuff. Again, we didn't even do an add one because there's just add them. It's nothing to it. Roman numeral 2, you've done before, but I don't know, last year may have been the first time you did it. And that is composition of functions. It just means like nested functions. F of g of x, like that. So you've done it before, but last year was the first time you've done it, so kind of take it from scratch here. What you might not have seen last year, it kind of depends on the teacher and textbook's preference of how they write things, is it written like that. F of g of x. Does that look familiar? Mm-hmm. Yes, good. They mean exactly the same thing, it's just different notations. And if we want to say it, f of g of x. So we're going to do some with numbers and some with variables. And for some reason, usually students find one of the other easier and one of them hard, but it varies by student which one they like and which one they don't like. F of x equals, we're going to use the same functions. F of x is 2x squared plus 2. We'll let g of x be x squared minus 5x plus 4. So same functions from above, but just to write them so we can see them again. So let's find f of g of 2. F of g of 2. I don't like that notation right there because it's tempting to do something with the f first. So I'm going to rewrite it. You don't have to rewrite it. If you're comfortable jumping straight to solving the thing, go for it. But to me, this looks better. It helps me make sense of the problem. It amazingly helps me to focus on, I need to do g of 2 first and then f. Right? Math, we start with the innermost parentheses and work our way out. This sort of looks like we should do f first. So let's find g of 2. So we look at the g function. Whatever's in parentheses goes in for x on the other side. So that would be 4 minus 10 plus 4. That would be negative 6 plus 4 is negative 2. It's not my final answer, though. That's just what g of 2 is. G of 2 is negative 2. So in place of g of 2, I'll put negative 2. Now we want to find f of negative 2. So we grab the f function, and whatever's in parentheses goes in for x on the other side. So f of 2, 2 times 2 squared plus 2. Whoops, negative. Although, when we square it, it wouldn't have mattered, but yes, should be negative. So 4 times 2 is 8, plus 2 is 10. So, like, none of the math is really that hard, like none of the computations are hard. It is just a matter of being careful, being neat, keeping up with where you are in the process. How about g of f of negative 1? G of f of negative 1. Well, again, I don't like that. I'm going to rewrite it like that because that helps me focus on what needs to happen first. You know what? Why don't you try that one? It's real similar to the last one. So you plug in negative 1 to f, you get 4. G of 4 turns out to be 0. Pause again, you try this one. F of 0. So sometimes the back-to-back f's mess people up. But again, if you rewrite it like that, I think it's fairly straightforward. So try that one. F of 0. Agree? Agree. Good. F of 0. So it works the same way. It's just sometimes when they see the same letter, people panic. But just do what it says. And we're not going to ask you to, but the test is already written. But each year I want to do like a bonus. It's like, something like that.
Do it.
It wouldn't be hard. You just have to keep up and be very careful while you plug that in, and then into that, and into that, and into that.
Do it.
You would just have to be careful. Kind of a slow down, take your time, be careful bonus.
That is a bonus. Would be awesome.
Yeah, most of you should get it.
Yeah.
Like, you know how to do it. The only mistakes would be like careless mistakes, because there's, in these type problems, if each of those required like 2 operations, like a squaring and a subtraction, but then you got to do that 4 times, so that's 8 or 10 little things you have to do without messing up. Hopefully you can do that. All right, let's try the composition with variables. F of x equals x squared minus 2, and g of x equals the square root of x minus 5.
How do you add a square root?
It is, you're right. So f of g of x. So instead of f of g of a number, we're going to do f of g of a variable. But it still works the same way. In fact, I wonder if I should not even separate these two as a and b, but just put them all together, because the process is the same. It's just we're plugging in x instead of plugging in 2. Pardon?
You just multiply them 2?
No, remember that's not multiplying. That's composition, f of g, which is another reason why I always write it like this, to help me see that this is not multiplying. F of g of x. So what's g of x equal to? Square root of x minus 5. So it actually turns out okay, some of you peeking ahead. So I'll take my f function, whatever's in parentheses goes in on the other side. So the f function is whatever the input is, square it and subtract 2. Whatever the input is, square it and subtract 2. Well, this works out okay then. It's not always going to be like this, but this one's kind of rigged because what happens when we square the square root? They cancel each other out. So x minus 5 minus 2 equals x minus 7. Now, here's the tricky part of this stuff is if we ask for the domain of f of g of x. So there's our sort of final answer. F of g of x is x minus 7. What's the domain of x minus 7? Yeah, all real numbers. I can plug in anything I want there. The trouble is, to answer this question, we have to answer the domain of f of g of x before simplifying. So we need to kind of back up to there and talk about the domain. You think it's going to be the same? Is that what? Not exactly, because I can't put in, if I put something in here that makes this negative, it's not going to work. So I've got to remember that whatever's under the square root has to be greater than 0, greater than or equal to 0. So for domain of composite functions, you got to check on the domain before you do anything, before you do any simplifying. So x greater than or equal to 5. Probably don't need to draw a number line for that one. 5 to infinity. Let me try to show you that on the calculator. So I'm going to... Yes, that's my phone. Have we not seen this before? So I put in square root of x minus 5 squared minus 2. So that should be the same thing as x minus 7. And it kind of is, but you can tell that the domain starts at 5 and goes from there because of that square root thing. So is it the same graph as x minus 7? Not exactly because of the domain. Number 2, let's do g of f of x. I don't know that this will affect you, but as teachers, we have to be very careful, and you should be careful in your notes, I guess, whether that's an open circle or a closed circle. Because if it's a closed circle, it's a dot, and it's multiplying. If it's an open circle, it means g of f of x, like that. So I try to make it clear. I think the worksheet is clear. So g of x squared minus 2. So that means I go to my g function, and whatever's in parentheses goes in for x on the other side. be the square root of x squared minus 7. I don't want to do the domain of that because it would be kind of complicated. So we're going to leave that one alone. Well, because x squared minus 7 would have to be greater than or equal to 0, which means x squared has to be greater than or equal to 7. It's a little bit. I'll stop there. Lastly, again with the f of f, whoops, I almost made the mistake of the open circle versus closed circle thing. F of x. And again, I'm going to rewrite it every time with parentheses rather than the open circle. Yeah, if you're comfortable with the open circle, that's fine. So f of x squared minus 2. So that means I need to look at the f function and plug in x squared minus 2. Again, it's a little bit confusing because x squared minus 2 is the f function, but I need to use it again. The f function is whatever the input is, square it and subtract 2. Oh, I don't think I want to FOIL that one in my head with that x squared in there. Maybe you could. X to the fourth. Minus 2x squared would be minus 4x squared. Plus 4 minus 2. So x to the fourth minus 4x squared plus 2 is f of x. Again, use composition, not multiplication. How about the domain of f of x? It would be, although be careful, before we answer that we need to look back up here before we start simplifying it. But it would still be all real numbers. So we're good on this one. Alright, today's assignment is worksheet number 6. And I do want to do a couple with you. Because they're hard, but because you may not have seen them before. So on your worksheet, turn to number 6. We're going to do A and C together because it uses pictures, and sometimes that messes people up. Although I would think they're easier, but we'll see. So 6A, f plus g of 3. Remember, that means the same thing as f of 3 plus g of 3. Is 3 an x value or a y value? Just the 3 is an x value, which means f of 3 is x or y? Y. So I want to know the y value of f when x is 3. So I don't have an equation, but I do have a picture. So I look at the graph of f, I find where x is 3, and what is the y value of f when x is 3? 2. So these aren't hard, there's no computations, it's just a matter of knowing where to look. So f of 3 is equal to 2. G of 3, again, just be careful, make sure you're looking at the right graph and the right x value. What's g of 3 equal to? 1. And then, so the answer is 3. I've not really worked to show. Yeah. Part C, f of g of 2. Well, G of 2, start on the inside. What's G of 2 equal to? 2. And then F of 2. Running out of colors. F of 2 is equal to 0. So yeah, those aren't hard. Once you get the hang of them, those are probably the easiest ones on there. But just be careful to make sure you're looking at the right F versus G and the X and the Y. It's just a be careful kind of thing.